Okay, year 12, I'm going to go through a couple of these very quickly. I'm going to do 10, 11 and 12, and I'll leave 13 for you, depending upon how quickly I'm able to get through these. So this is applications of calculus to curve sketching, and this is exercise 2.7. So I'm going to start with question 10. And if I look at question 10, and it's y equals, now I'm going to write this a different way, negative x cubed, because I like to have the powers, the highest powers of x first, negative x cubed minus 3x squared, and this is a general form, plus 9x plus 2. Okay, so I know it's a negative cubic, so the first thing I know is that it could do something like that. It might not have two turning points, it might just go like that, but I'm pretty sure it's going to have those two turning points because it says find any stationary points and inflection. Now remember, the y-intercept, there it is, and also a hint for the point of inflection is minus b on 3a, x equals, and we'll check that out. So it should be minus 3 on minus, so minus 3 is positive 3 on 3 times minus, so it should be minus 1. Should be x equals minus 1. And let's see what happens when we do it using calculus. So first thing we do is derive minus 3x squared minus 6x plus 9, derive again, y double dash equals minus 6x minus 6. Stationary points when y dash equals 0, negative 3x squared minus 6x plus 9 equals 0. I don't like that negative 3. I'm going to divide everything by negative 3. And that'll get me x squared plus 2x minus 3 equals 0. So what have I got here? X plus 3, x minus 1 equals 0. So I'm going to get x equals minus 3, x equals 1. I get my calculator. So it's not coming out. Geez, that took a long time. Now I've got 3 of them. Come on, get out of there. And if I go to my documents, it should be there. No, my desktop. There it is. I want this one. And up it comes. And here it is. So what do I want to do? I want to put that into the y equation, which I've got up here. And I'm going to use my answer because I'm going to do it twice. So I'm going to go negative 3 equals. That's my answer now. And I'm going to go negative my answer to the power of 3 minus 3 times my answer squared plus 9 times my answer plus 2. And I get negative 25. Okay, so y equals negative 25. So I've got this point minus 3 and negative 25. And over here I get x equals 1. So the beauty of having already done that, so if I just put 1 equals, there it is now my answer, go up, press equals, and I get 7. So over here I get y equals 7. I get 1 and 7. Okay, so at that point, y double dash equals, well, I'll put minus 3 into y double dash, minus 6 times negative 3 minus 6. Well, that's going to be 18 minus 6, that's going to be 12, which is greater than 0. Therefore, I have a min, because the concavity is concave up, min TP. And if I go y double dash over here, and I get minus 6 times 1 minus 6, so that's going to give me negative 12, which is less than 0, so I get a max TP. And then possible, I'm doing it underneath what we already know should be the point of inflection. Possible PI, y dash, double dash equals 0. That's minus 6x minus 6 equals 0. That means minus 6x equals 6, x equals negative 1. We already knew that. Look, it is. There it is. Look at that. Oh, yes, minus b on 3a. We need to check concavity, but first let's find the y value. Y equals, oh, lucky I've got my calculator still there, so all I have to do is go negative 1 equals, there it is, go up equals, I get negative 9, so bang, I'm back here, y equals negative 9 minus 1. So at x equals minus 1 minus 9, or negative 1, negative 9, what am I going to see? I need to check concavity. It's okay, I've already done concavity. Look over here at x, y double dash, so f double dash of negative 3 greater than 0, f double dash of 1 is less than 0, so concavity changes. Concavity changes. So thus it's a PI. Oops. Thus it's a point of inflection. Okay. So what's this going to look like? Let's see if this works. Hold on. I need to just click here because shapes. And I want that. There we go. Move it to there. So it's going through 2. So we use a different colour here. We use red. There's a y-intercept 2. I've probably gone a little bit too low there because we're going to go up to 7 and down to negative 25. So negative 3, negative 25. So negative 3 down here. And 1 and 7. So 1 and 7 will be somewhere up here. And the possible PI is at negative 1 and negative 9. So about there. Remember, not too worried about scale. Now, we know it's a negative cubic, and it should look like that. So what have we got? Points we need to highlight. We need to highlight this point, which is negative 1, negative 9, and that's a PI. We've shown that the y-intercept is there, and we've got a max TP here at 1 and 7. And down here, we've got a min TP at negative 3, negative 25. And when you start getting whole numbers like that, you think to yourself, yeah, okay, this makes sense because they'd probably give me whole numbers in answer to a question like this. Okay, wow, not too hard, negative cubic. I'm going to have to go, so I'm going to jump, I'm going to jump to 11. I'll see if I can get 11 and 12 done. 12's pretty easy, so let's see. And by the way, you're not meant to find the roots. You can't find the root of a cubic. You're not up to that, but if we now have a look at question 11, and question 11, what have we got here? Now, this is the other type you're bound to get. It's a quartic, all right? And, oh, sorry, I hope I'm not messing with you. 3x, 4x cubed minus 12x squared minus 1. So, y equals 3x to the 4 minus 4x cubed, was it? Plus 4x cubed minus 12x squared. plus 4x cubed minus 12x squared. What was the y-intercept? Minus 1. Minus 1. Okay, so what are we going to do here? Well, this is a quartic, and it's a positive quartic, so it could look like that. It may look like that. May even look like that. But I'm thinking it's going to have 3 turning points and maybe 2 points of inflection, but let's see what happens. So first, we also know the y-intercept is minus 1. So we'll differentiate and we get y dash equals 12x cubed plus 12x squared minus 12x. Oh, isn't that neat? Yep, that's going to become very easy to put equal to 0. Sorry, and that's not 12x, that's 24x. Sorry, 24x. And then we differentiate again, and we get 36x squared plus 24x minus 24. Okay, let's deal with the stationary points first. Stationary points when y dash equals 0. Okay, so we got 12x cubed plus 12x squared minus 24x equals 0. Let's take 12x out the front, and I get x squared plus x minus 2 equals 0, which means x can equal 0. And here, what multiplies out to minus 2? X plus 2, x minus 1 equals 0. Now, I'm just going to rub that out because I want to get this in order. So, if I just take this one, here's my first one, x equals, because I want to keep them, x therefore can equal negative 2. Then I'm going to put the 12x equals 0, so x can equal 0, and then I can have x equals 1. And I've got the points in order of how they're going across, so I'll be able to visualize it pretty easily. So y equals, well, again, I'm going to go to my calculator and I'm going to do that nice bit of work that I did before. So clear all that, and I'm going to go negative 2, and that's my answer. And then I go 3 times my answer to the power of 4 plus 4 times my answer to the power of 3 minus 12 times my answer squared minus 1 gives me negative 33. Negative 33. And I'll quickly do 0. 0 equals, go up. Well, I already know it, I don't need to do it, but this would be a good double check. Negative 1. And then I'll do 1. So I'll just put 1 equals, scroll up, equals negative 6. So at negative 2, negative 33, at 0 and negative 1, and at 1 and negative 6. So I'm thinking it's going to be that W. Now, I have to find what the second derivative does. So, but while I've got that, my calculator in that mode, I'm just very quickly going to do this so I can get the y value. So, possible PI, I haven't determined the nature of the stationary points yet, I'm just going over here. Possible PI when y double dash equals 0. So I get a possible PI when 36x squared plus 24x minus 24 equals 0. Divide everything by 12, and that gives me 3x squared plus 2x minus 2 equals 0. Let's hope this is easily factorisable. So 6, what multiplies out to 6 and adds up to 2? Oh no, nothing I know. So I'm just going to go over here, look at question 11. They didn't find them. Oh, damn. Damn, this is going to be hard. They didn't find the points of inflection. They do exist. There are 2 of them because I know they do exist because I know that this thing has 2 roots. I don't think the question actually said find it. Let's have a look. No, it just says sketch showing all stationary points. Well, okay, let's see if we can do this really quickly. I'm not going to be able to find the y values because this is going to get very ugly because I'm going to need a quadratic formula here. So x equals minus 2 plus or minus a square root of b squared. So it's 4 minus 4 times 3 times negative 2 all over 6. So it's going to equal minus 2 plus or minus a square root. What's that? 4 plus 24 is root 28 all over 6. And that's going to be minus 2 plus a bit, minus 2 thirds, minus 2 6. So minus a third plus a bit, and minus a third minus a bit. All right. Oh. So at least I know they exist. Let's go back here and let's deal with these stationary points. So here, what does y double dash equal? Y double dash equals, and I'm going to take that. So I'm going to go to my calculator and I'm going to put in minus 2 equals, and I'm going to go, what is it? 36 times my answer squared plus 24 times my answer minus 24. 72, which is greater than 0, so min. Let's go to the next one. Now I've got 0. When I put 0 in there, I'm not even going to use a calculator. Y double dash equals 24. Great. Hold on a minute. 24. No, negative 24. Thank you. Here, see, knowing that it had to be a max made a difference. And y double dash, when it's 1, well, that'll give me 36. Because 36 plus 24 minus 24, 36, which is greater than 0, which gives me a min. I'm going to quickly sketch this. Come on over here. All right, I'll go down a bit. So, here we go. Oops, here. No, I knew it would do that. So I have to undo this. Where's my undo there? Go back. Righto. I'm just going to draw it freehand because I'm running out of time. So, and this is going to be a very rough sketch. So I know the y-intercept is minus 1, and I know 0 minus 1 is a very important point. It's a maximum, so I'm going to put that there. There's minus 1. And I've got negative 2, right, so over here, and negative 33. So scale really bad down here. Here's negative 33. And then I've got 1 and negative 6, so there. Now, you're not meant to factorise that and get the roots, but we can at least show the stationary point. So this comes screaming down here, turns around. There's a point of inflection there, remember, at minus a third minus a bit. And then minus a third plus a bit, there'll be another point of inflection there before it shoots around and goes up there. And we should label what these points are. So this is the point negative 2 and negative 33. and this is a point 0, 1, and this is a point 1, -6. And I'm just going to check that. And they got 0, silly, 0, -1. Look at that. It's 0, -1. I'm just going to quickly get rid of that. And it's 0, -1. So it's down here. Now we can draw it properly. So it comes, come on, screaming down there, turns around there, and shoots up there. Put my arrows on, my arrow here. That's 1, -6, and this is the point. Zero, -1. I was rushing. All right, you have a go at 12 and 13. We'll see how you go when we get to class.